Alright, so the last thing from the 9.1 notes is cylinder. So we're going to look at three different things really for cylinders. We're going to look at the volume of a cylinder and the surface area for a cylinder. Alright, which again, the formulas are given to you on the formula sheet, and in these notes you do not have to memorize them, you just have to know when and how to use them. Alright, so a cylinder, and we will always use nice right, they won't be skewed cylinders, so there'll be this nice shape here. So this shape drawn on the page here is an example of a cylinder. Alright, so the cylinder involves a circle on top and a circle on bottom. Alright, there's a lid on top and a base on the bottom. And so when you find the volume, it actually involves the area of a circle. Alright, so the volume is the area of a circle, the area of the base circle, which should be the same as the area of the top circle. And then you multiply that by how tall the cylinder is, the height of the cylinder. And so the volume is pi r squared, the area of the circle, times height. That will give you your volume. That will give you how much space this particular shape takes up, how much, again, if you were talking about this was a can, how much the can would hold, the volume of the can. Alright, so that's the volume. That's the three-dimensional shape's space that it takes up. The other thing we're going to talk about is the surface area. So this is sort of like perimeter in a way. It's the area of all of the sides of the cylinder shape. Alright? So it's just figuring out what the sides are. Well, as it turns out, if you sort of take it apart, so this is what the shape is at the bottom here, you take it apart, there are two circles, as I talked about. There's the top circle, which is the lid, the top circle, which is the lid, and the bottom circle, and they're exactly the same. So you would find the area of the top circle and the area of the bottom circle. Well, that's where the 2 pi r squared comes from. You have two circles with the same area. The last piece is the area around. The area around, which if you peeled off, if you think about it as a can, and we'll do an example of this later, if you can, and you peel off the label off a can, well, if you hold that label out in front of you, it's a rectangular shape. All right, so that's the shape that comes out. The rectangular shape, well, the width of the rectangle is the height of the cylinder. And then as it turns out, the length would be the distance around the circle, right? When you pull it out, that's the distance around the circle. Well, that's the circumference of the circle. That's what that comes out to be. And so that's why that's 2 pi r. And so when you find the area of this rectangle, it's 2 pi r, the circumference of the circle, times the height. All right, and that's where the formula comes from. But you don't have to memorize the formula. But it is important to know where the formula comes from, because when we'll take it apart in examples. So again, it's always a good idea to sort of know, well, these are where the pieces come from. This is how the formula works. Always a good idea to know how formulas work. All right, so volume, the total space that the shape takes up. Surface area, what the shape is made of. So again, what the shape is made of. First example, the volume. Find the volume and the surface area of a cylinder whose radius is 4 centimeters. So again, if I were to look at the top and the bottom, have the exact same shape. The radius, again, for both of the top, this would be the top circle, this would be the bottom. The radius is 4 centimeters. We know the height is 10 centimeters, so the distance of that is 10. How much paper, so okay, I didn't finish reading the problem. All right, so I now have the radius, the height. We want to find volume, total surface area, and then how much paper will we need to make a label for the can. So I'll do the last question. I'll save it for last. So the first two things I'm going to do is find the volume and the surface area. So that's just using your formula. So volume is pi r squared times h. And again, you don't have to memorize it. You can look it up on the formula sheet. So it's just plug in. Volume is pi. Radius is 4 squared. Height is 10. Again, I always simplify the 4 squared times 10. So when you take 4 squared, that's 16 times 10. So this comes out to pi times 160. That's exactly what volume is. And then use the pi key on the calculator. Remember, always use the pi key on the calculator. And then I'm going to round to one decimal place. It comes out 502.65, so 7. And we're in centimeters. Volume is cube, so cubic centimeters. So the volume, how much this can would hold if we were to fill it with water, it would hold 502.7 cubic centimeters of water. All right, surface area. All right, remember, surface area is the area of the two circles, the top and the bottom circle, so it'd be 2 pi r squared plus the rectangular area, which ends up being the side, which is 2 pi r times h. All right, that's the circumference of the circle times the height. You don't just need to know the formula and how to plug it in. All right, so 2 times my 4 squared, 2 times 4 times 10. And again, I like to simplify the pi's first. And so this is 1632 pi. And that's 40 times 2, so 80 pi. And I can add the pi's. Or you can also type it in your calculator. But if you wanted to know what the surface area was exactly, it would be 112 pi. And then we use our pi key on the calculator times 112. So the surface area, so remember it's area, and so it's going to be centimeters squared. So it comes out to be, and again I'll write round to the whole number this time. So 351.86, so 352 centimeters squared would be the surface area. All right, so there's the volume and the surface area. So answer the first two questions. The last question is asking how much paper. And so basically what we want in this case is just this piece. We want to know how much paper would we need to wrap it around the cylinder. Well, it's that distance around, the area around, it's called the lateral area, not that you need to know that. All right, but that's what it is. And so we want this piece. We want the surface area excluding the top and bottom. And so all we want is this piece of the surface area formula. The label area is that rectangle where I find the area 2 pi RH, the area of the circle, or the distance around each circle and the height, which we already found. That's this piece here. Right? Basically, I exclude the circle parts, and all I want is the area around. And so I already know what that is. That is the 80 pi. And then I have to take my 80 pi. I use my calculator to find pi. So 80 pi comes out to 251.33. So I'm just going to round to 251.33 centimeters square. Would be how much you need for your label. All right, so how much paper would you need? You'd need almost a little over 251 centimeters squared of paper. That's how much paper you would need in order to label this particular can. All right, so that was, again, the area on the outside, just the rectangular area. This would be the total surface area. This is just that one piece excluding the top and the bottom. All right, next example. A restaurant serves beer in cylindrical pitchers, so it's a cylinder, that are 6 inches in diameter, 7 inches tall. How many milliliters of beer will the pitcher hold if it is known that 1 cubic inch is equal to 16.4 milliliters? Okay, so there's two parts to this question. First, find the volume, how much water will, or how much beer will hold. And then once you know how much beer it will hold, you can do that in inches, because they give you inches. Then the last step is you want to convert your cubic inches to milliliters, and they gave us the conversion for that. All right, so first, we're given a pitcher. That's a cylinder shape. Bear with my cylinder shape. So this will be my pitcher. I know its diameter, which would be the distance across, is 6 inches. I know its height is 7 inches. We want to find the volume, which is pi r squared. Pi r squared times h. So I need my radius. I have my diameter. I need my radius. So remember, radius is 1/2, or the diameter divided by 2. It's half the diameter, so 6 divided by 2. So my radius is 3 inches. So volume is pi times 3 squared times 7. And so, again, I write it out first without using the pi key on the calculator. So 3 squared 9 times 7, so 63 pi. And then use the pi key on the calculator. Actually, I'm going to leave it exact. We're not going to round to the end. That's right. Don't round until the end of the problem, so I'm going to leave it exactly 63 pi cubic inches. Or again, inches cubed is just the easier way to write, because I want to convert. All right, so that's how much beer we can put in there in cubic inches. We want to figure out what is that in milliliters. All right, so they gave us the conversion that 1 cubic inch is equal to 16.4 milliliters. All right, so that's the conversion factor I'm going to use. All right, so we started off with 63 pi, which is my cubic inches. The conversion factor, well, I want to get rid of inches, so my 1 inch cubed goes in the bottom. The 16.4 milliliters goes up top because I want to keep milliliters. I want to get rid of inches cubed. And then you multiply. Now, we're going to multiply it out. So now you're going to take the 63 pi times the 16.4. When you multiply that out, that will give you your milliliters. And sorry, I misspelled this horribly here, but whatever. You guys know what it is. All right, so get out your calculator. 63 times the calculator key pi times the 16.4, and the volume in milliliters comes out to be 3245.89. So I'm going to round up to 3246. Round to the whole number. Liters of beer. About, since I did a round. That's how much beer in milliliters. All right, so 63 pi cubic inches converts to 3,246 milliliters. All right, that's where I'm finishing up the notes. The very last thing, if you look and see, look at the notes, I've got some example problems, and I'm giving you the answers too. All right, so again, the idea is that you see if you can do these. If you can't, post them in the forums, and I can help you out. Now, I'm going to kind of get you started on all of them, so I'm actually going to pop it up in my completed guided notes. I've actually got, I didn't do it all the way out, but I did get you started on them. And I'm going to talk about that in the next video.